Have you ever wondered about the scariest theories that science doesn't even mention? What if I told you that there is a dark side of scientific knowledge, full of mysteries and disturbing discoveries that challenge our understanding of the universe? Today, let's explore these terrifying theories that scientists prefer not to discuss openly. The butterfly effect is a powerful metaphor illustrating how small actions can have immense consequences in the future. Imagine that the simple flapping of a butterfly's wings in Brazil could trigger a tornado in Texas. This highlights the coexistence of probabilistic and deterministic modes in the operation of the universe. Small, seemingly insignificant events can expand into a chain of unpredictable reactions, shaping the world's destiny in surprising ways. To better understand, consider how a trivial decision in your daily routine can completely change the course of your life. Imagine a person named John. One day, he decides to leave home 5 minutes earlier than usual to get a coffee before going to work. This seemingly trivial decision changes the course of his day completely. At the coffee shop, he meets an old childhood friend, Mary, whom he hasn't seen in years. They start talking, and Mary mentions a perfect job opening for John, something he wouldn't have found otherwise. This casual encounter leads John to a new career opportunity, changing his personal and professional trajectory in unimaginable ways. This example illustrates how small actions can trigger a chain of events with significant consequences, highlighting the beauty and mystery of the butterfly effect. The mystery of the butterfly effect invites us to look at the universe from a new perspective. The space around us is not just a stage of random events but a dynamic fabric of interconnected causes and effects. As scientists explore these ideas, they reveal the complexity and beauty hidden in the apparent simplicity of nature. Chaos theory reveals that what seems like disorder may actually have a deep and organized connection. A fascinating example is the game of chaos, where random points, when repeatedly applied, form the Sierpinski triangle, a symmetrical and ordered structure. This phenomenon illustrates how order can emerge from chaos, demonstrating that the universe has its own hidden rules and patterns beneath the apparent surface of disorder. Imagine a dynamic system, like the weather, where small changes can result in significant variations. In the 1960s, Edward Lorenz, trying to improve weather forecasting, discovered that small differences in the initial conditions of a weather model could lead to drastically different outcomes. He realized that exact long-term weather prediction was impossible due to the chaotic nature of atmospheric systems. This showed that while we can identify general patterns, specific details can be extremely sensitive and unpredictable. Chaos theory helps us understand that the universe is a complex web of interactions where order and disorder coexist. It challenges the traditional view of a mechanistic and predictable universe, proposing that even simple systems can behave unpredictably. This opens the door to new ways of thinking about science and reality, where uncertainty and complexity are recognized as fundamental parts of nature. All this leads us to explore the sensitivity of dynamic systems, known for their extreme sensitivity to initial conditions. Small variations at the starting point can lead to drastically different results, making many natural phenomena chaotic and nonlinear. A classic example is the behavior of animal populations, where small environmental changes can result in unpredictable fluctuations in population numbers. This demonstrates how the universe is interconnected and how even the smallest factors can have significant impacts. Think of a double pendulum, a simple physical system that, when set in motion, exhibits chaotic behavior. Even small variations in the initial force or release angle can result in completely different trajectories. This unpredictable behavior is fascinating and illustrates the complexity of dynamic systems. In the economic field, for example, small changes in policies or seemingly insignificant events can trigger economic crises or booms, highlighting the unpredictable nature of these systems. The beauty of dynamic systems lies in their ability to reveal complex patterns from simple interactions. They show us that nature is full of mysteries and that science is constantly unraveling new levels of complexity. As scientists study these systems, they discover that unpredictability and sensitivity to initial conditions are fundamental characteristics of the universe. In chaotic systems, even in apparent disorder, there are underlying patterns that repeat stably over time. These patterns are known as strange attractors. They guide the behavior of chaotic systems, creating repetitive and predictable structures within the chaos. Think of snowflakes or fern leaves. Each of these natural forms exhibits repetitive complexity, a direct reflection of strange attractors. Imagine a river flowing through a winding valley. The flow of the water may seem chaotic, but it follows a path dictated by the terrain's geography, the attractors. In the universe, these attractors can be seen in weather patterns, planetary movements, and even galaxy formations. They are the invisible molds shaping the behavior of dynamic systems, allowing science to find order in what seems random. Edward Lorenz, while studying the weather, observed how strange attractors could influence atmospheric behavior, revealing an unexpected level of organization. The presence of strange attractors reminds us that behind the complexity and chaos, there is an underlying order governing the universe. These repetitive patterns are fascinating because they emerge naturally, without external intervention. They show that nature has an incredible capacity for self-organization. This reminds us to consider fractal geometry, which describes how irregularity is a consistent property at different scales in natural phenomena. Fractal geometry reveals that irregularity and complexity are consistent properties at different scales of natural phenomena. Think of mountains, whose rugged surfaces exhibit a similar pattern, regardless of the scale at which we observe them. This self-similarity is a fundamental characteristic of fractals. Another example is trees, where the branching of limbs follows a repetitive pattern from the main trunk to the smallest branches. Fractals are not just a mathematical curiosity, they have practical applications in various fields of science. In space studies, for example, the distribution of galaxies can be analyzed using fractal principles, revealing a self-similar structure in the universe on a large scale. This demonstrates that the complexity of the cosmos can be understood through simple and repetitive mathematical patterns. Scientists use these patterns to make predictions and even better understand the structure of the universe. This self-similarity found in fractals helps us realize that the universe has an underlying order, even in the most complex and irregular forms. As we explore unpredictability and determinism, we will see how these concepts intertwine to create the fascinating tapestry of reality. Even in systems governed by deterministic equations, unpredictability can arise due to sensitivity to initial conditions. The butterfly effect is a classic example of this phenomenon, where small differences in initial conditions can lead to drastically different outcomes. This highlights a fundamental truth about the universe. Despite having physical laws that govern phenomena, the complexity and interconnectedness of systems can make their predictions extremely difficult. Imagine launching a marble on a complicated track. Even if you know all the acting forces and the initial position, small variations in force or angle can result in completely different trajectories. This is the essence of unpredictability in deterministic systems. In the universe, this means that while we can understand the basic laws that govern space and matter, predicting the exact behavior of complex systems, like weather or social dynamics, is almost impossible in the long term. This relationship between unpredictability and determinism teaches us that the universe is both ordered and chaotic. Modern science recognizes that uncertainty is an inherent part of reality and that the quest for absolute predictions is often frustrated by the intrinsic complexity of systems. This understanding paves the way for more flexible and adaptive approaches in science and everyday life. By exploring these terrifying theories that scientists don't even mention, we open a window to the complexity and mystery of the universe. We discover how small events can trigger large catastrophes and how apparent disorder hides a deep and fascinating order. These discoveries challenge us to look at the world with new eyes, recognizing the interconnectedness and sensitivity of initial conditions that shape our reality. By better understanding these dynamics, we can better prepare and adapt to the world's uncertainties. If you enjoyed this journey into the unknown, don't forget to subscribe to the channel and turn on notifications. Join us to continue unraveling the mysteries of the universe and diving even deeper into the fascinating world of science. Until the next adventure.